Good morning, everyone. My name is Laura Hatch. I'm owner of Flexo Global, and I'd like to welcome you to this FPPA-sponsored webinar titled Latest Developments in Flexo Plate Solutions for Corrugated Printing. I'd like to cover a few agenda items before we get going. I'm going to tell you a little bit about Flexo Global. We're going to make some introductions. That will be followed by the presentation, and then it will wrap up with a Q&A session. First, a little about Flexo Global. We're an expansive information portal for the global flexographic printing industry. In 2013, we had over 2 million hits, making us the place to go to get your Flexo news and information free of charge. And now I'd like to introduce FPPA's president, Dan O'Brien.
Thank you, Laura. Good morning. On behalf of the Flexographic Prepress Plate Makers Association and our board of directors, we thank you for joining us. Today's webinar is sponsored by Kodak. Also, special thanks to John Anderson of Kodak. John is an FPPA board member who first introduced the idea of educating our industry through webinars. Thanks again, John. The FPPA seeks to create, promote, and enhance high standards within the flexographic pre-press plate making industry through leadership, vision, direction, and education. Our 2015 annual meeting will be held in conjunction with the AICC in Naples, Florida. We hope you can attend. The FPPA membership is open to all plate makers and suppliers. If you are interested in becoming a member of the FPA, please contact me directly at dan_o@dynamicdies.com, or you can call myself or reach out to Diane Schaefer. Thank you. Laura will now introduce our presenters.
Thanks, Dan. Now I'd like to tell you a little bit about today's presentation, which is about the latest innovations for increasing print quality in a preprint and post-print applications while keeping a close eye on production efficiency and cost control. The presenters will share technology developments that impact both solid ink coverage and highlight reproduction and support the discussion with real-world print data. Our first presenter is Emma Schlotthauer, Global Marketing Manager, Packaging Solutions at Eastman Kodak. Based in Minnesota, she has over 25 years experience in the printing industry and spent her formative years in Kodak research and development and technical support roles before taking on sales and marketing positions. She's been responsible for global marketing for the award-winning Kodak Flexcel NX system since its launch in 2008 and is a regular contributor to publications and a frequent speaker at industry events. Our other presenter is Dr. Andreas Albut. He leads Kodak's worldwide packaging R&D activities, including development of the Flexcel NX and Flexcel Direct systems, and works closely with the Unified Workflow Solutions team on software solutions with a focus on screening and pattern development for packaging. With an extensive background in color science, he is also responsible for the development of Kodak's Spotless software and ongoing enhancements to Kodak's approval proofing solution. Andreas brings over a decade of print experience across Flexo, inkjet, and offset to his role. And with that, I'd like to turn it over to today's presenters.
Well, thank you, Laura, and thanks everybody so much for joining us today. Sounds like we do have a bit of an echo, but I hope it's coming over clear for everybody. So let's get going anyway. Here's a quick overview. If we just go to the next slide, it's a quick overview of what Andreas and I are going to cover today. I'm going to start off with a very quick overview of who Kodak is today, and then take you very briefly through what we've been up to in Flexo over the last few years. At that point, then, we'll really get into the meat of the presentation around corrugated applications. And Andreas is going to cover most of that content. We're really pretty new in the corrugated segment, and we are definitely learning every day. But we want to take the opportunity to share some of the exciting results we've been seeing from taking our latest Flexo plate technology and applying it to a variety of different corrugated preprint and postprint print conditions. And then, of course, at the end, we'll leave a little bit of time for some Q&A. So let's take a quick look at who Kodak is today. So Kodak is a very different company than the one that most of us grow up knowing. And with revenues of around $2.35 billion and just around 8,000 employees serving our customers all over the world, today we're really focused exclusively on the commercial printing businesses. And packaging is one of three core businesses. And at the heart of that, we have our Flexcel NX system business that's really our flagship product and is growing rapidly at about 30% every year. So we've been in the digital Flexo plate business with the Flexcel NX solution for about the last 6 years. And in the development work leading up to the launch of that product, we decided to take a different approach to digital Flexo plates than what was currently established in the market. Within our own stable, we already had LAM's imaging technology in our portfolio in the form of the ThermoFlex range of imaging devices. And at that point, we could have chosen to follow that technical path. But with the ultimate goal of being a transformation in terms of quality, stability, and consistency, we decided to select an imaging technology that had really served us well for those features in the offset printing industry for many years. And today, with over 16,000 square spot imaging enabled devices in the market, that technology really comes with an excellent track record. And what it really did is it allowed us to leverage the benefits of using a high resolution dye-based mask rather than imaging a traditional carbon layer. And that's some of really what makes the Flexcel NX system different. There's definitely been a major industry shift over the last few years towards the use of digital flat top dots in Flexo, and it's definitely a core feature of Kodak's technical approach. And for our users, we see benefits across all applications, from fine features to solids, and are firmly committed to using flat top dots across all of our applications. So what really makes the Flexcel NX system different then to other flat top dot solutions that are out there? The important thing is that it really starts with imaging, and that's where the difference comes. As I said before, we decided not to go with the traditional LAMS technology that we already had in-house, and instead opted for the low energy square spot imaging, where we could create a highly controllable, repeatable and precise mask for plate making, and that's really where the difference starts. So that choice enables us to be able to achieve one-to-one reproduction of the bitmap file to the plate. It removes all the opportunity for error in plate making and drives consistency and predictability in plate making, which is really the beginning of where things need to start. What it also does is it enables extremely fine features to be reproduced on the surface of the plate. And Andreas is going to talk quite a lot about the use of surface screening patterns for corrugated printing shortly. So I wanted to be sure to introduce the basic concept of DigiCap NX patterning here. So precise imaging and a one-to-one reproduction of that image allows a pattern of 5 micron elements to be created across the entire plate surface. And those are features, as you can see here in the image, that manifest themselves as tiny islands on the surface of the plate, and the surface of the imaged areas of the plate, which really allow ink to flow around those islands during the transfer process from plate to substrate. And it's a technique that has been extremely successful for film substrates, but most importantly for the market that we're talking about today, very successful for uncoated papers. So to support our venture into the corrugated segment, we made a couple of key product announcements this summer. Firstly, the Flexcel NX Wide 5080 system, which now enables Flexcel NX plates to be made in formats up to 50 by 80 inches, and a new, softer plate material designed specifically for corrugated post-print applications. It's a material right now that's available in 112 or 155 thicknesses, or 2.84 or 3.94 millimeters for those of you that are living in the metric world. And it also comes with a brand new thermal imaging layer, or the mask material that I was talking about earlier, that's been designed specifically to work with the 5080 format. So before we move on and talk about post-print applications, which is really where Andreas is going to focus his time, it is worth noting that the new 5080 format has opened the door for using Flexcel NX technology in preprint liner applications as well. So using the original Flexcel NX H plate, not the softer one that I just talked about, which is now available in a 50 by 80 format size, customers have been reporting the ability over the last few months to achieve offset-like image reproduction, and most interestingly, some significant advantages in plate longevity. We believe it has a lot to do with the unique dot formation and shoulder angles that Andreas is going to talk a bit more about later. But let's move on to post-print, okay? And that's going to be the main focus of our discussion today. And as we start to focus on the post-print market, from a plate perspective, we see a market that's in transition to digital, especially at the high end, and an environment where flat top dots are generally accepted as being required to help with issues such as washboarding and fluting and things like that that we encounter in corrugated printing. But the real question is, what other opportunities lie out there that plate technology developments could potentially help with? Depending on the applications and the type of graphics that we're trying to reproduce and the type of boards we're working with, we might ask whether there's opportunity to seriously compete with preprint quality. With such huge pressures on cost and packaging reduction targets, we might also ask whether there are opportunities to move to lower weight or lower grade boards without compromising print quality. And also whether improvements in ink transfer could not only help visual appearance, but maybe also allow increased press speeds and utilization. So these are the questions we've been asking ourselves, and with the combination of the Kodak imaging technology I talked about, the plate materials, and the surface patterning, we've been putting some of those to the test, and this is the part that I'm going to hand over to Andreas and let him take you through some of the results we've been seeing.
Thanks, Emma. Thanks for sharing the background, and I'm excited to talk about some of the results, what we've seen with our latest plate development. It has been an exciting development. We've seen actually a lot of very positive feedback with the customers. We worked throughout a nearly 2-year development to bring this plate to market. And overall, the NXC plate, as Emma highlighted, is actually a unique plate and brings some new exciting opportunities to the table for corrugated customers across the board. One of the key aspects for this technology is actually the dot formation control, what we have. As you've seen in some of the earlier pictures also from Emma, we can actually form dots very precise, and we have also the ability to produce a very good shoulder angle, which is actually one of the key ingredients why we actually have a differentiated solution for the corrugated applications. It has actually 2 key aspects. One is low highlight gain, and the other one is robust on-press performance. One key is always, how do I make sure that my highlights stand up over time from that perspective? The other aspect, what we put tremendous effort in, is leading a new patterning development to complement the solution. And the patterning development, as Emma highlighted, has actually tremendous impact on the overall density performance, what we achieve. And as she highlighted, and we'll get into this into more detail, is it actually gives us opportunity to save ink or push our densities actually way up. And you'll see some of the results, real press results, what we've seen with a number of the customers we worked with. To formulate a new plate, we obviously had to also choose the diameter of the plate very carefully, but also as part of the pattern development, we looked at very carefully how we actually minimize fluting, which is obviously a key concern for all of you. Another key aspect, what came up multiple times throughout the work, is in order to actually get the best possible results, we found a key is always low analog pressure, low impression to actually especially drive good highlight performance. And we get into that also in more detail, what is driving that and what we need to pay attention to. But overall, we see actually the NXE plate as an opportunity for you to extend the capabilities, what you bring to a range of corrugated applications. The first one, what I want to talk to you about is cutting costs. When we look at a new development, we look at not just what we can bring as technology to the market, but how does it benefit our customers. And from a cost perspective, we looked at multiple aspects. And one of the interesting ones in corrugated is, how do you reduce board costs? Because today, in order to produce a good board, you often, or most often, use a coated board. And the cost of that is obviously noticeably higher. What some of the technology, what we're bringing with the NXE plate is unprecedented densities, what we can achieve. And what it allows us to do is actually look at lower grade face stocks to actually push the performance on the density to become actually much closer than what you used to for the coated boards. So it's not necessarily perfectly the same example, but they get actually now much, much closer than what we ever seen before. And that gives you opportunities to talk to your brand owners and customers, how do you actually can deliver cost savings and continue to grow your business. The surface patterning, as Emma highlighted, is actually a key part of delivering densities. First of all, when you look at fundamentally, how do you drive densities up? And the key part is how well you transfer ink, how you uniformly lay it down, and obviously from a cost perspective, how you do it with the lowest amount of ink. We have two technologies, and they're built one on top of the other. As Emma highlighted, we've built our expertise first in the wide web flexible market, especially for the development of standard DigiCap NX. And that has been our core. And we advanced it actually more recently with our latest series of advanced DigiCap NX patterns, where we looked at higher ink volumes, which is one of the key differences, what you see obviously in the corrugated market. To give you an example, some of the things what we are able to achieve with this pattern technology. You see the patch on the left-hand side is actually a picture of a real coated sample board, printed with a 600 LPI analogs, which was able to push actually density all the way up nearly to 2 for a cyan color. When we look at this on an uncoated board, we went to a larger volume analogs roller. We ran, in this case, with a 300 LPI analogs roller, and we're able to push the densities to 1.26. And this is actually, when you look at it from a typical density level, actually very close to what many people produce today on coated board. So that's where we're seeing the benefits on how we actually can look at, can you modify what face stocks you use to save your customers cost and differentiate yourself. And the core on this is the pattern and technology, what we apply. Looking at some of these real examples, there's two different press tests shown here. We're showing printed density versus percent tint. On the right-hand side, you can see this on a coated substrate, and you can see this particular example showed us densities nearly in the order of 2, which is really an amazing result. On the left-hand side, this is, again, a different press, different set of analog rollers, different set of inks, where we competed directly against 2 of our competitors. And we were also able there, relative to the competition, show actually further increases in terms of what we can deliver, with an example here of 1.45. The other part, what we're seeing in our results, across the board, we're seeing actually very good low gain densities in the middle part of our gain curves, which is another benefit for a very good tonal range across the board. Looking at what do we actually do in patterning, and this is the latest range of analog pattern compatible surface patterning, what we actually apply to our Flexo plates. If you look at the top one, the top 3 patterns were actually developed for processing. So we actually look at what analog volumes are required to make patterns work. On the left-hand side, our standard DigiCap NX pattern, where Emma highlighted, it's a 5 by 10 micron, very fine pattern. Works actually extremely well, even with low analog volume. As you can increase your analog volume, which is common in corrugated, we can see that bigger patterns help us with a number of things. They help us with some of the densities, but they help us also with the fluting characteristics. So what we call here Advanso 1 and Advanso 2 are 2 additional patterns within. The bottom ones were dominantly developed first for white ink, but then also see some applications in high volume corrugated applications potentially. So here again, we continue to increase the ink volume from the left to the right-hand side, where, for example, the left-hand side ranges up starting from around 4 BCM all the way to above 10 for certain applications on the right-hand side. So these patterns were very much designed similar to how you design an analog system from the ground up. Instead of giving you, for example, a very large range of just patterns to try, we actually very carefully designed the flow characteristics and ink transfer characteristics to give you a minimum set of patterns to help you with the optimum implementation and optimum results on press. This next slide shows you some of the extreme examples how patterns work and hopefully bring some of the additional understanding how things tie together. On the top, we show a very, very low unlocks volume, in this case 1400 LPI unlocks roller, which is rather uncommon in corrugated, but actually serves as a good example on the extreme side. In the middle, we use a medium volume unlocks roller, 600 LPI unlocks roller on a coated substrate as well. At the bottom, we look at high unlocks volume, 300 LPI roll on uncoated board. What you see from the left to the right is actually increasing patterning size from the standard digicap being at the very left to actually a reasonable large size checkerboard on the right-hand side. So as you increase the patterning size, you can see actually when you use very little ink, standard digicap NX pattern, the very fine pattern, works well. But then very quickly you start actually not filling the pattern appropriately and you actually print the pattern. So you can see that very well in the top example. When you actually step up the amount of ink, you can see a different range of patterns work well. And this plays a key role in terms of how you design the flow characteristics of the pattern. So here you can see a range work in the middle, and then suddenly you can see actually quite clear transition where the pattern doesn't work anymore. You're starting not to fill the pattern properly, you don't have enough ink volume available, and you're printing the pattern again. As you go up further in volume, you actually can cover most of the required ink volume fairly well, but you also see at the very right-hand side that fluting is becoming very noticeable on that side, and you're not filling the pattern perfectly as well. While if you look at the left-hand side, you actually get very nice uniform results. So this should give you a sense of how patternings work and how they tie actually to unlocks volumes. So if we look at some of the examples what we presented here for density, how can they actually help us, especially for 1 and 2 color jobs, which is a large fraction, obviously, of the corrugated market. First of all, as we highlighted, you can look at it, if you can push up density, you can look at how can you utilize it to drive cost down. You can look at it reducing ink usage. So if you can run actually 1 unlocks volume down and still achieve the density what your customers are asking for, you can actually pocket a significant amount of money with the reduced amount of ink. Alternatively, you can use the additional density to actually utilize a lower grade face stock and still deliver the results, what your customers are looking for in terms of image pop. The other aspect is for certain spot colors or certain applications, you can benefit on putting more image pop in place. You can show reduced fluting in many applications. Overall, we actually see a fuller tonal range, and as I mentioned earlier, low gain, which is again a key part of that. When you actually drive down the amount of ink you're using, especially with some of the limitations in ink drying in corrugated presses, this raises also the opportunity to potentially raise press speeds or how you actually deal with overprints, because that's one of the key challenging aspects. How do I dry my ink fast enough? The other aspect is because we're actually a flat top dot plate all the way from highlights to solids, we're actually seeing very good plate life across the board. And overall, how are we able to deliver this? It's driven by our patterning technology through digicap NX. It's driven by the flat top dot technology core to the NX technology, and then the optimized shoulder angle, what we're benefiting for corrugated. Now let's look at the other side of the spectrum. Let's look at the highlight side. What can we do? And in this particular graph, you see dot gain versus the highlight tonal range. You see the bottom 2 curves, cyan and magenta, for an NXC plate, and above a competitor's plate, again, cyan and magenta. The key difference is not all flat dot solutions perform the same. You will see significant differences in terms of how the highlights perform. In this case, you see actually quite noticeable different highlight dot gains, with the competitor showing actually significantly larger gains. This is one of the amazing things what we've seen with our plate. We see very excellent low dot gains across the board. And this is actually shown in this particular slide. Here we're looking on the left-hand side, the competitor plates, on the right-hand side, the NXC plate, at a typical low-end corrugated solution where we're looking at 60 LPI, so nothing too high-end from that perspective. But you can see on the left-hand side quite significant gains in the highlights, but then you also see in the midtones quite a significant difference how the two solutions differ. Now, when we look at highlights, there's a range of things what we need to pay attention to, and that's in many ways core to all flat top dot solutions or even general printing in corrugated. What you will be well aware of, obviously, but some of the things which actually can help you in addition. First of all, board quality. That's table stakes. If your board is not flat, you will have a hard time producing good highlights, because the only way you can actually make an uneven board work to some degree is by using high impression. High impression kills our highlights. We all know that. So board quality is actually the core. It's not the face stock quality. We can actually do now with the higher densities a lot for face stock, but if we have uneven board, we will have a hard time making actually a good highlight dot. Unlux pressure, again, once we have a flat board, we can actually bring our unlux pressure and impression down to good levels so that we don't crush our highlights. The next part, as highlighted earlier, our plate has a very good ability to hold dots very well, highlight dots. You have very good shoulder angles, dots which actually stand up under the tremendous pressures what you see overall in corrugated printing. Then the surface patterning, for us, that's key part to the solids, but you need to be able to bring this all the way across the tonal skin into the highlights to make sure that you don't have any discontinuities and a smooth transition across the board. The other aspect where we put over the last 2 years tremendous effort is how do you actually develop screens which can actually give us the dot sizes and better dot control in the highlights. And hybrid screens have continued to evolve, and our latest development has been around what we call Maxtone SX screening, a very good highlight screen where we actually enabled customers to provide a lot more control over highlight dot size with a really good opportunity to fine-tune what is required for their processes as well as the shadows. And then last of all, we all know that if you look at a drawdown in a vignette, if you have the highlights on the leading side on the impression, you always see more of the classic highlight bump, while the trailing edge will always produce a smoother drawdown. So that's another thing from day-to-day implementation perspective on press. You can actually drive your improvement as well depending on the job details. Going further, this is another slide just showing out what we can do on hybrid screens. Many of the different screens on the market, you can generally separate between fast transition hybrid screens. Here you can see on the left-hand side a rather sharp transition from FM to AM. On the right-hand side, we really see a very smooth hybrid. This is actually an example of our Maxtone SX screening, and we can really dial in that minimum dot. And that actually helps us to produce a very good fade to zero while we're keeping actually the appropriate dot size. Looking at how far we can push the performance, this particular image is a picture of a press test, in this case a corrugated board, an E-flute with a coated board, so good stock, good even stock, and you can actually produce amazing vignettes fading all the way down to zero. In this case, we used our hybrid screening. We actually went through all the different highlight dot sizes, and they actually all performed in this particular case very well. And this is not just an observation what we've seen in one instance, but in multiple instances with customers. So it depends on your press capabilities and overall press performance, what you can hold. This will vary to some degree for every printer. But in a good high quality press, you can look at 2x2 dots, probably as the bottom end, and going to 4x4 dots if you need overall more robustness. And even though if you look at the top side is you see very good fade downs to 0, the slightly larger dot size in the minimum dot will actually help you with robustness over time as well. So that's where fingerprints and press tests become important to really understand what you can deliver on your press. So now look at how can we actually understand how far this technology goes. And we entitled the slide, "Don't try this at home," because this is not your normal print condition. But we wanted to see how far can we push the technology, how does it fail? And in this particular case, we pushed our evaluation all the way to 175 LPI. We compared the competitor's flat top dot plate against the NXC plate. At the bottom graph, you see the magenta and cyan for the NXC. On the top side, you see the competitor's magenta and cyan. And this is where you start seeing really the differences. Oh, sorry. If you look at it, the competitor's plate, you start the increasing highlight gain, really resulting in poor highlights, which is not surprised. That's what people expect. But what we've seen with the NXC plate really is the difference that we still, see some gain in the highlights, but much, much less. So from that perspective, we know actually we built a very robust product from a highlight dot retention perspective, how we can stand up on press. We also see, both more gain in the midtones, but you can see in the competitor plate, overall, a much higher gain. So again, the strength, what we've seen across the board, is very much on high densities, low gain, very good highlight performance. So what does this have as an implication for 4-color process? We haven't talked very much about pre-press, but there's also benefits on that side. So if you look at the full tonal range, what we can achieve for some of the applications, not all of the applications will have full tonal range, obviously, but it will actually help you with getting better images produced on corrugated in general. If you look at, from an imaging perspective, our NX system utilizes a thermal imaging layer, in general short TIL. That one is very lightweight overall, and we have no risk from that perspective of it flying off the imager, compared to the risk when you look at very heavy plates common in corrugated. From a speed perspective, the patterning technology doesn't slow our imaging solution down. It gets applied at full imaging speed, so you have actually good ability to maintain your throughput in prepress. Actually, our throughput overall is very high. One of the challenges what you often see in the corrugated market. If you look at it, we produce 100% flat top dot solution, so you don't have to actually apply any special items. How do I need to treat the highlights versus shadow? A very simple process across the board. The smaller file sizes for high definition are also a key benefit on our system. And from a plate making perspective, we see very fast processing of the plate overall. When we compare it to many of the competitor plates, we see actually excellent timing. Another unique aspect from a plate making perspective is we apply a long UVC exposure, which gives us really a very nice slick surface to release ink. And that's one of the additional key aspects to actually get the good ink transfer we've been seeing. From an equipment perspective, the NX system will also give you an opportunity to utilize it for some of the analog plates, what you use day in and day out in many applications. We have a DITR film which can be used in those applications so that you have actually broader use of the equipment. If we look at the printing aspects, again, highlighting some of the same points as already made, the ink transfer is core to our solution. We can bring cleaner and brighter colors, and we have the opportunity to reduce impression with a good ink transfer. You don't have to push very hard on your plate to get a good ink transfer. The choice of densities or ink saving becomes yours in this particular case because we have so much ink transfer capability that you can look at how do I actually pull back on my ink, how do I save on that side, how do I can potentially take advantage of now easier drying and potential higher press speeds. You can get the great tonal range and contrast in the image with the opportunity to save on lower face stock. The other aspect you may want to keep in mind is as it's common, many of your brand owners are looking for sustainability goals, and this may help them with that as well. Now, let me turn it back over to Emma.
Thanks, Andreas. And before we just kind of move on and wrap up the presentation portion of this webinar, I wanted to just take the opportunity, I think Andreas has made it fairly clear as we go through, just to remind you that it's the combination of the imaging, the plate material, the unique plate making process, and the surface patterning technology really that all come together in the Kodak Flexcel NX system to really make the results that Andreas has shown possible. So let's kind of summary. Let's just sum it up. Our focus is on using our technology to help you improve visual impact and reduce cost at the same time, and that's irrespective of whether you're focused on process color printing or not. And we do this by addressing the key areas of ink transfer and highlight image reproduction. So we recognize that we're new in this part of town, in the corrugated market, but I do want to stress that Kodak is firmly committed to continuing to bring innovative technology into the corrugated space. We believe that there's significant opportunity to apply our technologies, and the reality is that that goes way beyond Flexo as well. An example of that is our partnership with the leading press manufacturer in this segment. And they've chosen to work with us because of our strength in digital print technology. So the commitment that we make to the corrugated market is not just what we're doing in Flexo plate technology, but also what we're committed to do with our digital print technologies as well. It's really an exciting time for the corrugated industry, and as Kodak, we're really excited to be part of it. So that really wraps up the presentation portion of the webinar. And I thank you for listening to both myself and Andreas. And I do believe that we've now got some time for questions. I'm going to hand it back over to Laura.
Thank you, Emma. I'm going to turn the screen back over to Flexo Global here. That will change. And while we're waiting for that to happen, I have the first question in the queue, which is, I noticed in your slides that you showed print densities of 1.98. Why should you want to print at such a high density?
Okay, excellent question. Typically, you will not use such a high density for a typical process colors because it would show, very poor results in terms of your color reproduction. But by looking at the relative density you can achieve for a given amount of ink, it gives us two different strategies or three different strategies to save money. One is you're stepping down in the ink volume, what you're delivering, and that way dropping your ink density. The other opportunity is what we've seen actually in the wide web flexible part a lot is people using extender. And from that perspective, driving down your pigment cost overall and driving down your ink cost. And the third opportunity, as mentioned, is really focused around pushing up the performance with lower grade space stocks. And there you can see you get much more reasonable densities, actually something which will actually help to actually give you better color reproduction when you go on uncoated board. I hope that answers the question.
I hope so too. If it doesn't, I'm sure a new question will come in. Question number 2, what's the smallest dot you can form on the plate with this solution?
The NXC plate by design is actually capable to hold a 10 micron dot, as we can do currently on our NXH plate, but we don't recommend that in this particular solution. In the corrugated application, you want to actually be focused on robust dots. So from a typical application perspective, in high-end printing in corrugated, I see typically a 2x2 dot, which is in this case approximately 20 microns by 20 microns as the minimum dot. But for a broader range of applications, it may go up to about 40 by 40 microns.
Okay, question number 3. In one of your trials, you were using a 1400 line analogs. I don't know of any corrugated printers with that type of equipment. Are the results relevant to everyone?
So a 1400 LPI analogs is rather a rare animal, what you see in corrugated printing. This was actually on a real corrugated press, and it was actually a very interesting result. what it actually was used in this particular presentation to really just highlight how patterning technology works and how we actually need to understand how the flow characteristics of the pattern work and how it changes when you look at different volumes. In general, I would say, very, very few printers will ever look at this type of analog solver, but it will help you to understand how surface patternings work and how you actually can apply them to yourself. And if you see failure in patterns to work, and in this particular case, you really start seeing the pattern to print, that actually gives you the confidence, okay, now I know what I'm actually looking at. And one of the fixes for some of the patterning challenges, what you may see is that you have insufficient ink. So it's just a demonstration element in this particular case.
Okay, question number 4. I might have missed it in the presentation, but what plate calipers are available with the new Kodak plate?
We currently started our solution with 3 calipers. As Emma highlighted, it starts from a 112 to a 155 with also a 125 caliper available. So that's our starting point. We will see from a customer request perspective if we will go thicker in the solution over time. But that's, from the current market, what we put our focus on.
Okay, question number 5. Will plate thickness be available for 250?
At this point, we have not extended the solution for that thickness. It comes down to what customers will be looking for. If we see a lot of requests for that, we will continue to evaluate it, and I would anticipate to bring a solution to market if there's a good opportunity to help customers with that.
Okay, question number 6. Are the new screen patterns going to be available in TIFF Assembler 3.0?
So what we have in TIFF Assembler Plus 3.0, we actually bring another technology to market for Flexcel NX, which we actually call HyperFlex NX, which actually is a different approach where we support highlight dots actually better. This can be utilized also on corrugated plates. It helps you actually with the typical challenges when you look at screened dots, that you have often smaller partial dots. Even if you set your hybrid screen or your typical screening, let's say to a 20 micron minimum dot size, you will often find smaller ones. Or if you pick 40 microns, you may see 20 micron dots. And often those end up forming scum dots. So that's the technology in TIFF Assembler Plus 3.0, where we're extending opportunities to our customers to improve highlight dot stability. What we actually will bring out in the next version is actually what will be TIFF Assembler Plus 3.1, which we just started beta with, is actually the advanced pattern set. So that will come out very soon to the full range of customers.
Okay, question number 7. Why are you not offering 0.125 plate? What is more commonly used in the U.S. corrugated printing?
Absolutely. That was one oversight from Emma. Yes, we absolutely offer a 125 plate.
Okay. Question number 8. I don't know whether how you can answer this. How competitively priced is Kodak to existing flat top dot technology?
Emma, do you want to answer this one?
Absolutely, I can definitely take this one. So Kodak plates are competitively priced, and they are priced according to the value that they deliver. That's an individual pricing discussions obviously are something that we do one-on-one with customers. So I can't really say any more than that.
Okay. I think that is the end of our questions. I will give people a chance here as kind of I wrap up. If something comes in before we wrap up, I will ask the question. I did have one question come in asking if this webinar will be posted to Flexo Global's website. Yes, it will, as all our webinars are, and you will be getting that information early next week in the newsletter and posted on the website for that information. So while we're, wait a minute, let me see, I've got one more question before we wrap up. Will this plate transfer a higher percentage of ink from the analog cell volume than a standard plate?
Our experiences in general is the amount of ink you're transferring remains very, very similar. There may be subtle differences, But the key is always around how you most uniformly lay the amount of ink what you have down to achieve the highest density. And that's really the trick and focus on what we have done in the patterning technology, what we applied. It's all about uniform ink laydown. That's actually what helps us to drive the ink up, or the density up, sorry.
Okay, I think that is it. So with that, I would like to extend my thanks again to FPPA for sponsoring this great webinar. I know there was a lot of valuable information offered, and it will be posted so people can review it. I have one more question that has just popped in. It says cell volumes. What were the differences in cell volume, BCM, between the 1400 and 300 LPI rolls?
If I remember correctly, the 1400 was in the between 2 and 3 BCM, while if you look at the 300 was in the, I believe, 6 BCM range. Okay.
One last chance, everybody. I'm going to be wrapping up in a minute or two here, so if you have a question, get it in. If not, please feel free to send it to me, Laura H. at flexoglobal.com, and I will forward it to our presenters so that they can answer you directly. If you are interested in hosting a future FPPA webinar, please contact their executive director, Diane Schaefer. Her email is below, Diane at stringfellowgroup.net. That information will also be part of the recorded webinar if you're looking for it and didn't write it down. The recorded webinar will be posted to the Flexo Global website. It should be going up Monday, Tuesday at the latest. Look for the link in Tuesday morning's newsletter or on our website homepage. Is there anything you would like to say, Emma or Andreas, as we wrap up?
No, I don't think so. Once again, I just want to thank the FPPA for the opportunity to sponsor this webinar, and to you, Laura, and Flexo Global for hosting.
Yeah, and same. I would like to echo the same things and the opportunity to show some of the technology and results what we can bring to the market. So very much appreciated.
I have one last question, if you have the time to take it.
Absolutely. It is,
what durometer would you recommend to help avoid flute voiding on recycled board?
Not an easy answer. We typically see ranges from a 30 to mid 40 durometer. That's actually the range what we evaluated from that perspective. When we looked at where we pick our optimum durometer, we're sitting closer to the 40 number. When you look at the fluting size plays obviously a significant role in that. And what actually helps us is a combination of what we do in the patterning and also in the flat top dot solution, plus combine it with the shouldering. So it's not a simple answer. In this particular case, we offer one durometer, which applies to obviously a range of different scenarios. And a softer plate in general will help you to pull the fluting further down, but then you will pay with it in general with more challenges to produce good highlight dots. So there's a trade-off in there, and we carefully studied how we actually pick best for an overall solution.
Okay, with that, it's our last question. I would like to thank everybody again. A special thanks to the FPPA. Look for your newsletter on Tuesday for this recording so that you can share it with your fellow workers, anyone that might be interested in this information. Thank you so much and have a great day. Bye-bye.